This video is going to focus on understanding ions. Ions are atoms, or it can also be a group of atoms that have a positive or a negative charge. So some examples of just individual atoms that can have a charge would be sodium. Sodium is going to typically get a positive charge. We'll talk about why. Calcium, a positive 2 charge. Iodine, a negative charge, oxygen, a negative 2 charge. So those are individual atoms. There are also groups of atoms that will bond together and have a charge. For example, OH is a hydroxide ion. It has a negative charge to it, but this is what we call a polyatomic ion. And that means poly means many and atomic means atoms. So this is a ion that's made up of more than one element. We also, because we've got positively charged and negatively charged, a cation is what we call an ion that has a positive charge, and an anion is what we call a ion that has a negative charge. So you get a cation, positive charge, from losing an electron because you're going to have more protons left. If you gain something a negative, that is negative, like you gain something with a negative charge, an electron, you're going to have more of that negative charge. So you're an anion then. Cations and anions are going to form from gaining or losing electrons. So in the outermost orbital, there are electrons. So magnesium, for example, has 12 protons, which means it also has 12 electrons. So the first energy level has 2 of them, and then the next energy level is going to have 8 of them. And after that, we need 2 more still. And so those are going to be in this energy level here. Well, if I need to have 8 electrons, I could either gain 6 more electrons to fill that outer shell, or I could just lose the 2 that I have. So basically, it's kind of easier to just lose these 2. Well, if I lose 2 negative things, I'm more positive. Therefore, I have a positive 2 charge. The same way works with an anion, except with an anion, it's going to be gaining electrons. So let's look at fluorine. Fluorine has 2 electrons in the first orbital, always 2 in that first one. It has 9 protons, so we're going to be filling up 9 electrons. So that means in this next orbital, we need 7. And so with 7 electrons, I'm just 1 short of having my full set that I need in order to be more stable. So that's exactly what it does, is it gains 1 more electron, and since it's gained a negative, it now has a negative 1 charge to this ion. Because the periodic table is arranged according to the number of protons, that means that if we have a neutral atom, they're also arranged according to the number of electrons. So we can make some general predictions because of that. On our periodic table, we have elements that are metals on the left side, and we have nonmetals on the right side. And so because the metals that are on the left have 1 valence electron in their outer shell, or 2 valence electrons in their outer shell, or 3, it's much easier to lose those electrons. And when you lose electrons, you end up with an overall positive charge. So these guys on the left side tend to form positive ions or cations. On the right side are nonmetals. Because they already almost have a full orbital, they're going to form negative ions, and they're just going to gain 1, 2, or 3 extra electrons and be negative. Let's do some practice together next. First thing I need to point out is how you're going to see ions written. Most of the time, you're going to see an ion just written with the element symbol and then the charge next to it. Now, the only reason I've given a little bit more information is so that you don't have to pull out your periodic table. When you see numbers to the left, the number at the top is going to be the mass, and the number on the bottom is going to be the atomic number. Okay, so I've just given us some information, extra information there so that we don't have to pull out a periodic table. So this tells me, remember the atomic number is also the number of protons. So I'm just going to fill that in right away. For potassium right here, I've got 19 protons because the number on the bottom, that's the atomic number. Oxygen here, 8 protons. It's the number on the bottom. That's the atomic number. That's the number of protons. Calcium on my third example, 20 protons. It's the number on the bottom. Now, before I worry about my positive or negative charge, I'm going to go ahead and use my other number that's here, which is my mass. So remember that my protons and neutrons are going to equal my mass. So I just figured out my number of protons. So that means that if I've got 19 protons, that's contributing to my overall total of 39 mass right here for potassium. So 39 minus 19 is going to be 20 neutrons. On the next example, I have 8 protons and a mass of 16. So that means my neutrons must be the other 8 mass that I need to have there. Then finally, for calcium, if I have 20 protons and a total mass of 41, 41 minus 20 is going to be a mass of 21 neutrons to contribute to that. Now let's figure out electrons. Before, in a neutral atom, you would have the same number of protons as you do electrons because we would want our positives to be equal to our negatives in a neutral atom. But these atoms are not neutral. So I have one extra positive. So that means that I've got more positives by 1 than I do negatives. So that must mean that I only have 18 electrons. See how I've got one more positive thing. So now oxygen here has a -2. So that means that this -2, that must mean that I have more negatives than I do positives. So, and I need to have 2 more of them. So I've got 8 positives. That means I need to have 10 negatives. And then finally, we've got calcium. Calcium has 20 positives. We have 2 more positives than we do negatives. So that means that I need to have more positive than electrons. So my electrons has to be 2 less. So I must have lost 2 electrons. Always try to do some practice on your own. So this diagram here helps you with seeing the charge of some common ions that we have. So like I mentioned before, it's all based because of the number of valence electrons. So this very first column, or the first group, they tend to have a +1 charge to them. And the reason they have a +1 charge is that they only have 1 valence electron. So they get rid of that 1 negative, hence leaving more positives. The next column works the same way. They've got 2 electrons in that outermost orbital shell. Well, it's easy to just get rid of 2 negative things. If you get rid of 2 negative things, you're left with more positives. On the other side of the periodic table, so again, these are metals. They tend to be cations with a positive charge. And then on the other side, we have the opposite happening. In group 7, we have 7 valence electrons. Well, it only needs 1 more in order to have a full orbital. And so it's real easy to just gain 1 more negative thing than try to get rid of 7 negative things. So it gains that 1 more negative, and it's negative by 1 more. The next column, pattern follows, and we have a -2 charge, and then gaining 3 electrons for a -3 charge. Aluminum's the only one in column 3A that's going to get a charge to it. So that's the only one that's going to have a +3 charge. And then carbon, if it's going to form an ionic bond, that one just sometimes it'll be a +4, sometimes it'll be a -4, but you'll learn how to figure out which one it is. There are also names to all of these different groups. The first column are the alkali metals, the second the alkali earth metals, Then in the middle are the transition metals. These guys have different kinds of charges. That's why I ignored them. You'll usually get a paper to give you information about that. And then these guys over here are called halogens and noble gases. You don't have to memorize any of those. The two columns that are on the bottom here, they've actually been pulled out and they belong right in here, but because it would make our periodic table look odd to have a whole bunch of stuff suddenly and then a big gap, they pull them down here for that purpose. Finally, just to show you some of these items, kind of interesting, this is sodium metal. Sodium metal is a very soft metal. You can actually cut it. That's one of the elements in group 1A. The alkali earth metals includes magnesium, which ignites very easily. I'll actually do this in class to show you magnesium lighting, and we'll talk about what kind of chemical reaction that is. Halogens are known as the salt makers because they will create different kinds of salts. So fluorine, chlorine is actually by itself a poisonous gas, but when it bonds together with sodium, it makes table salt. Bromine, iodine, also some of the halogens there. And then finally we have what are called the noble gases. These guys are very unreactive. They have the full 8 valence electrons, and so they don't react. A lot of times they're used in signs as well as an insulator in double pane windows.